Hi, in this video we are going to solve question number 4 of GATE 2019 physics paper. It is from differential equation. The question is, for the differential equation d2y by dx square minus n into n plus 1 y by x square is equal to 0, where n is a constant, the product of its two independent solution is, there are four options. So basically this is a second order differential equation, and we have to find the roots of its second order linear differential equation and then find the product of those independent solution. So we can write this equation as d2y by dx square with x square coming in front. Now this type of second order differential equation are known by a special name known as second order Cauchy Euler differential equation. This is because we have not a constant term. This x square term which is coming in front of d2y by dx square is not a constant term. Therefore, it makes this problem a little complex. So there is a way to solve this question, this kind of second order Cauchy Euler differential equation. So let us take a new variable t, such as x is equal to e to the power t. Therefore, dx by dt will be exponential t, and we can invoke chain rule and write dx by dt as dx by dy times dy by dt, which is equal to exponential t. This is using chain rule. Therefore, dy by dx will become 1 by exponential t dy by dt. Okay, so dy by dx will become 1 by exponential t dy by dt. Now we'll differentiate both sides. With respect to x, so we'll get, with respect to t, so we'll get d by dt of dy by dx is equal to d by dt 1 by exponential t dy by dt. Now we can again invoke chain rule here and write LHS as d by dx dy by dx times dx by dt. So this using chain rule, and this we can differentiate using product rule. 1 by et d2y by dt square. Now I'll differentiate 1 by et, so it will give 1 minus e to the power t dy by dt. Now we know that dx by dt is nothing but exponential t, so we can write exponential t, and this will become d2y by dx square. This will become d2y by dx square, and from the right hand side we can take out 1 by exponential t common, so we'll get d2y by dt square minus dy by dt. Okay, now this will make exponential 2t d2y by dx square. Now this term e2t d2y by dx square is nothing but x square d2y by dx square, because x is equal to exponential t. Therefore, from here we can use this and this, so this will become x square exponential 2t is nothing but x square and d2y by dx square. So which is essentially the first term of a differential equation. So first term of differential equation can be written as d2y by dt square minus dy by dt. This is very important. Let us take it as 1. This is 1, this is 2. Therefore, substituting 2 in 1, substitute 2 in 1, we get d2y by dt square minus dy by dt minus n plus 1 y is equal to 0. Now this has been reduced to a simple second order linear differential equation, order linear differential equation with constant coefficient. There is constant coefficient, and we know how to solve this question. We can just assume y is some, let us assume solution is, assume the solution y is equal to exponential r to the power t. Now we'll put this 3 in 2, maybe you can write it as 3, and this is 4, we can write this as 4. So we'll put 4 in 1 and we'll get something like r square exponential rt minus r exponential rt minus n plus 1 y is equal to 0. Now we can take out exponential r to the power t constant, so we're left with r square minus r minus n plus 1 y is equal to 0. By definition, exponential r t cannot be equal to 0, so we are left with the auxiliary equation r square minus r minus n plus 1 to 0. Now we have to factorize this quadratic equation. So now to do that, what we'll do is that we have to do some adjustment. So this r we can write as minus r n plus 1 minus n. So this r can be written as like this, okay, like this. Because this n cancel out, so it will again become r. Now what we'll do is that we'll just open the second bracket, so we'll get minus r n plus 1 plus rn minus n plus 1 0. Now we can take r common from first and third term, and we can take minus n plus 1 common from second and fourth term. So what we are left with is and therefore r is equal to minus n plus 1. So we are got two roots of this differential equation. Now what we'll do is that we can write, and these two roots are distinct and real because n is constant. So we have got real and distinct roots. So the solution will become y is equal to c1 exponential minus nt. First root is minus n, second root is n plus 1, plus c2 exponential n plus 1 t. Now we know that x is equal to exponential t, therefore y will become c1 times exponential, because e to the power t is x, so e to the power minus t, so it will become x to the power minus n, and this will become c2. We can write as x to the power n plus 1, or multiple, and we can write as c1 upon, sorry, there is a mistake, pardon me, it will become c2 x to the power n plus 1. So we have got the solution of this differential equation, and the two independent solutions are 1 by xn and x to the power n plus 1. And we have been asked in the question, then what is the product of these two independent solution? So the product of two independent solution will be 1 by x to the power n times x to the power n. This will cancel out, so we are left with x. So option B is correct. So this is the way through which we can solve this question. Thanks for watching this video.